us start with a look at slings, made of flexible steel wire rope. The safe working load of a sling is the maximum load that may be lifted after considering the safe working load of the sling material, the reeving arrangement and the method of sling termination. The loading factor of a flexible steel wire rope is a combination of reeving factor and angle factor. Let us now look at some hitches for single slings. This is a single sling direct load. One end of the sling is on the crane hook, while the other end is attached directly to the load. A tagline is used to prevent load rotation. The loading factor is 1 multiplied by the safe working load of the sling material. This is a single sling reeved around a rectangular load. One end of the sling is passed around the load, then up through the other end and placed on the hook. Load control is limited with only one sling rigged in a choker hitch. A choker hitch will never provide full 360-degree contact. The loading factor is 0.5 multiplied by the safe working load of the sling material. The choke point should always be on the sling body, not on the sling eye, fitting, base of the eye or fitting, splice or tag. This is a single sling reeved around a round load using a choker hold. The loading factor is 0.75 multiplied by the safe working load of the sling material. This is a single sling reeved around a round load using a choker hold. This slinging method does not grip the load completely and should be used only when the loads are easily stabilized or cannot slip out of the sling. The double choker hitch, if applied properly, will facilitate equalization of the loading on the sling legs over the lifting hardware. If applied improperly, one of the legs will share a greater portion of the load and equalization will not occur. The double choker hitch workload limit is twice the regular choker hitch workload limit. On the left is a basket hitch around a round load with a load factor of 2. On the right is a basket hitch around a rectangular load with a load factor of 1. The sling cradles the load while both eyes are attached overhead. As with the choker hitch, more than one sling may be necessary to help ensure load control. A basket hitch should only be used when the sling is passed through part of the load and the load is balanced on the sling. The lifting should not commence until a shackle is connected to the sling legs. The included angle of the sling should not exceed 90 degrees. This diagram shows the loading factors for a single sling reeved in a basket hitch with angled legs. If the angle between the sling legs around a round load is 30 degrees, then the loading factor of the sling is the safe working load multiplied by 1.93. If the angle between the sling legs around a round load is 60 degrees, then the loading factor of the sling is the safe working load multiplied by 1.73. If the angle between the sling legs around a round load is 90 degrees, then the loading factor of the sling is the safe working load multiplied by 1.41. If the angle between the sling legs around a round load is 120 degrees, then the loading factor of the sling is the safe working load multiplied by 1. And for rectangular loads with the basket hitch and angled legs, if the angle between the sling legs is 30 degrees, then the loading factor of the sling is the safe working load multiplied by 0.97. If the angle between the sling legs around a rectangular load is 60 degrees, then the loading factor of the sling is the safe working load multiplied by 0.87. If the angle between the sling legs around a rectangular load is 90 degrees, then the loading factor of the sling is the safe working load multiplied by 0.7. If the angle between the sling legs around a rectangular load is 120 degrees, then the loading factor of the sling is the safe working load multiplied by 0.5. When using multi-leg slings, we should ensure that the slings are of the same length. Where the slings have different safe working load ratings, then the load that can be lifted is related to the least safe working load, and the attachment points of a two-leg sling to the load are far enough apart to give stability without exceeding 90 degrees. This diagram shows two slings with a choker hold and the hitches formed in opposing directions. This diagram shows two slings with a choker hold and the hitches formed in the same direction. The two-leg slings used in choker hitch, basket hitch, double wrap choker hitch and double wrap basket hitch should not be used for handling composite loads such as loose bundles or tubes, bars, or wooden battens unless the friction grips between the parts is sufficient to prevent them slipping from sling. As far as possible, such composite loads should first be tied up securely at their ends by steel wires or similar means of adequate strength. Under the angle between the legs of the slings. For example, the weight of the load to be lifted is 20 tons, and the angle between the legs of a two-legged sling is 60 degrees. This means that the load factor is 1.73 for the angle. The weight is 20 tons. The angle factor for 60 degrees is 1.73. Therefore, the safe working load of the wire should exceed 20 divided by 1.73 or 11.56 tons. Therefore, use a sling with a lifting capacity greater than 11.56 tons. Let us consider the reeve factor as well as the angle between the legs of the slings. To calculate the maximum weight of load that can be lifted, multiply the SWL of the sling, or slings, by the angle factor and by the reeve factor. The SWL of each leg of a two-legged sling is 8 tons, the angle factor for the 60 degrees between the two sling legs is 1.73, and they are reeved around a square load having a reeve factor or 0.5. The maximum weight that can be lifted is equal to 8 times 1.73 times 0.5 or 6.92 tons. The location of the lifting points and the length of slings used relate directly to the angles involved. Choose wisely. Sling termination factors depend upon the type of termination and rope size. This table provides termination factors for commonly used termination methods. To simplify selection of the appropriate wire rope sling, it is usual to combine the safe working load of the rope material with the loading factor to produce a safe working load chart. This load chart is for 6 by 24, 1570 grade, galvanized steel wire rope. The safe working load for various rope sizes and slinging configurations has been combined to enable the safe working load to be taken directly from the chart. The only correction which may need to be made to values taken from the chart will depend upon the method used to terminate the sling. Chain is considerably heavier than wire rope of the same lifting capacity, but is more durable. It can better withstand rough handling and can be stored without deterioration. Always check that the grade on the tag matches the grade markings on the chain. Do not use if there is no tag on the chain. Chain slings are often used for lifting heavy items on work sites, such as skip bins, concrete slabs, and pipes. Chain slings are made up of lengths of high tensile chain, with a variety of fittings attached. To calculate the safe working load of lifting chain in kilograms, multiply the diameter, in millimeters, squared, by the grade, by either 0.3 or 0.4. For grade 80 chain, use 0.4, and for grade 30 or 40 chain, use 0.3. To calculate the diameter, in millimeters, of chain needed to lift a given load, divide the load, in kilograms, by 0.4, and by the grade and find the square root of the result. In the case of two-leg sling used in basket hitch or a four-leg sling, the angle between any two diagonally opposite legs should not exceed 90 degrees unless the sling is so marked. In no circumstances should the included angle exceed 120 degrees. Spreader beams, spreader bars, or lifting spreaders are a long bar that keeps two slings apart from the lifting distance. It is designed with two lifting eyes at the top of the beam. For a three-leg sling, any one leg should make an angle of not greater than 45 degrees with the vertical. For a four-leg sling, any one leg should make an angle of not greater than 60 degrees with the vertical. The safe working load of slings depends on the safe working load of the sling material, the reeving arrangement and the method of sling termination. The safe working load of a flexible steel wire rope, in kilograms, is the rope's diameter in millimeters, squared multiplied by 8. If a wire rope has diameter 12 millimeters, its safe working load in kilograms is 12 squared, multiplied by 8. That is 144 multiplied by 8, or 1,152 kilograms, or 1.15 tons. If we have to determine the size, or diameter of wire, in millimeters, to lift a known weight, we divide the weight, in kilograms, by 8, and find the square root of the result. If we had to determine the size, or diameter of wire to lift 1152 kilograms, we divide 1152 by 8, and find the square root of 144. Let's look at determining the maximum load that can be lifted. This chart shows how the safe working load of the same wire changes when the angle between the legs changes. We start on the left with the legs vertical or 90 degrees, we can lift 1,000 pounds. The load factor for 90 degrees is 1. Then second from the left, we see that angle between the legs is 60 degrees, we can lift 866 pounds with the same wire. The load factor for 60 degrees is 0.866. Second from the right, we see that angle between the legs is 90 degrees, we can lift 707 pounds with the same wire. The load factor for 90 degrees is 0.707. On the right, we see that angle between the legs is 120 degrees, we can lift 500 pounds with the same wire. The load factor for 120 degrees is 0.5.